Okay, today we're going to review algebraic expression. This is one of the easiest topics. This is one of the easiest topics that one can ever encounter in terms of mathematics in high school. So let's get going. So today we'll be looking at the laws of exponents. The laws. I want to zoom in. Today we will be looking at the laws of exponents and the definitions associated with it. So the first law states that if the bases are the same, as you can see here, the bases are the same is a to the exponent of m multiplied by a to the exponent of n. That means we add the exponents, then we keep the base, then we add the exponent m plus n, m plus n. The bases are the same, is a and a. We add the exponents. As you can see from the example here, they did the same thing. The bases are the same. They added the exponent that they get 7. So exponent 7. Then again here, if the bases are the same and we divide, we minus the exponents, then here you can see it will be a being kept, which will be m minus n, like this. Then here again, if it is in brackets and you have m inside and this one, then we're going to multiply them through. This is the same. Even if we have n inside, then we multiply everything through, then we get whatever we need. Every time when we have things in brackets, even if you can have 2 to the exponent of 2, 3, this thing is equal to 2 to the exponent of 2 times 3, which is 2 to the exponent of 6, which is exactly what they did here. That is the law. Then again here, if we have bases here and have an exponent, we're going to take it and multiply it here, take it also and multiply it there. Then we're going to arrive to a situation like this. Very, very much simple. Like here, we're going to take this and multiply it with that, take this multiply this, take this multiply that in the exponent. Remember, we deal with the exponent. We have a base and an exponent. This is an exponent. Exponent. Then here we're talking about something called base, as you can see. So from here, we got a base and we got also an exponent. These things are very, very much crucial to know. Then here we're going to have a divided by b. We're going to take it and multiply to the exponent there, multiply also to the exponent there until we arrive to a situation like this, which is that. Then here they took it, multiplied there, multiplied there. Then they got everything in order. As easy peasy as that. Then exponential definition state that if a is to the exponent of 0, we get 1. Any number to the exponent of 0, we get 1. Any number to the exponent of 0, we get 1. Any number to the exponent of 0, we get 1. So if we have 1 to the exponent of a, we get also 1 for all element of real numbers. This is what it is being said. For example, even if you can come here, it will be the same thing. 1 to the exponent of 0.2008, it will be equal to 1. I was attending a problem this side. Okay. If we take 1 to the exponent of any number, we get 1. Meaning, if you can see 1 to the exponent of 70 is equal to 1. 1 to the exponent of 600 is 1, always. And here we'll be talking about in fraction form. Always, if you have a number to the exponent of a negative number, can be converted into fraction like this. Then again, x to the exponent negative 4 equal to 1 over x4, like that. If you can have 2 negative 1, this is equal to 1 over 2, always, like that. These things doesn't change. They are always like that. So the other thing is we got a base and x to the exponent negative n. Remember, this thing is like a multiplied by x to the exponent of negative n is equals to, always, a comes at the numerator to be a divided by x to the exponent of n. So the way in which we're going to be doing this is like a multiplied by 1 over xn. Then this thing is equivalent to a over xn as we multiply it above. As you can see here, this one comes above. How did they do this? It's like 3, 1 over x to the exponent of 4, which is equals to 3 multiplied 1 over x to the exponent of 4 is 3 over x to the exponent of 4. Then you get whatever you want. Then again, if you have a fraction like this, simply just is 1 over this in bracket to the exponent of n, like that. Then if you have something like this one you apply something called reciprocal. Reciprocal method is like this. If you have 1 over, this thing can be converted into a fraction. It will be like 1 over x to the exponent of n, which will be equal to, reciprocal method will take this one and we keep the 1 at the numerator, which is this one. Then we're going to take this one and put it in the numerator, take this one, put it in the denominator, times xn over 1, which is equal to x to the exponent of n. Always like that. Then here is the same. Remember, it's just a number here. A is just a number or a variable. So it's like a multiplied by 1 over x minus n, which is equivalent to a xn. Why? Because this comes from this definition, which is equals to a xn. Simple as that. Then here also you do the same thing, but the only thing just is 1 over a. Then you do the same thing, it's gonna go above. Then you get this. These laws, you just have to know them properly and very, very well for you to be able to come and ace them. Let me try to zoom out. What's happening here? Let me try to wrap these things. Then again, we have this law. This law, they also apply to reciprocal. If we have a fraction like a over b to the exponent negative n, this thing is like you apply reciprocal. Why? Because if you have this thing can be converted into 1 over a over b to the exponent of n because of this negative. Then from here, you can just apply reciprocal and have b over a to the exponent of n, which is what they did there. Another thing, if we have a negative m divided by b negative n, they're saying is equivalent to that, because we know what any number to the exponent of a negative number, it will give us a fraction. So it will be equals to 1 over a to the exponent of m divided by 1 over b to the exponent of n. Then all of this thing, we're going to keep the numerator, which is going to be 1 over a to the exponent of m times this one. We take this one and put it above at the numerator to be b to the exponent of n divided by 1. Then this multiplied by this, we're going to have bn, and this multiplied by that, we're going to have am, which is what we have then. So then I also are living the problems. Let me share this page. Are living in very simple problems. So here they are saying we have 2a squared multiplied by 3a multiplied by 0. Then the thing that we already know is that if the bases are the same, we add the exponent. And if the base like this, they are the same. These bases are the same, but the numbers in front, they are not the same. Meaning we don't keep the base with the number. We have to multiply this 2 with this 3. Then we have 6a. Then the basis, because they're the same, is going to be 2 plus 3. And we know that any number to the exponent of 0 is 1. Then here we'll be having another situation, which will be 6a to the exponent of 5. Then it will be our answer. Then this is our first problem. Then our second challenge to look at, we have 5. We got 5. What's happening with me? We got 3 to the exponent of 5 multiplied by 3 to the exponent of 3 divided by 3 to the exponent of 2 multiplied by 3 to the exponent of 6. Here, because the bases are the same, we add the exponent. It's 3 to the exponent of 5. Because here, if this is only a number, there is a 1 as an exponent there. Then we're going to add plus 1 plus 3. Then this is equal to 3. 2 plus 6 is equal to 2 plus 6, which is equal to 3. 5 plus 1, we get 6. Plus 3, we get 8. Then divided by 2 plus 6 is 8. 3, 8. That means our answer is... Eh? Let me see. Oh, here's 9. Sorry. 9. Okay. Nine. Then, if the bases are the same and we divide, we subtract the exponent the same. 3 to the exponent 9 minus 8.
Which is 3.
Eh? is equals to 3 to the exponent of 1, which is equals to 3, just like that. Then that is our answer. Then we're going to finish an example to make class activity. Firstly, we have negative 3a cube b to the exponent 2 divided by a to the exponent 5 b to the exponent 3. Secondly, we have 2x divided by 8y minus 4 to the exponent negative 3. This is a class activity. Then the close send another link to join or receive it at Skydra or online. Then try the corrections to these problems. Once you leave.
Yeah, Captain.
Yeah, this is true. Then more feature one on Rumelo WhatsApp who want to pay the corrections. Sure. It'll end this meeting.